Good afternoon, my name is Amanda Gagne, and today I'll be sharing Module 2 practices. The question was provided for us in this scenario: what is the best land cover for a healthy watershed? As an agricultural teacher, I thought about what I would use in my own classes, and I came up with the idea of looking at rotational grazing pastures for livestock and the soil health. So here's a quick video of kind of my setup. So I had the 3 bottles. The first one would have been grass. It was not growing, so that would be something I would change. The second bottle was soil with fabric on top, and the third bottle will show you here in a second, but it was a bottle with soil, then stone, then soil again. When we're thinking about a livestock pasture, we try to do these methods within the pasture to go ahead and prevent soil erosion, to keep the soil health pretty healthy. This bottom model here could have been grass. It could have been another type of cover crop as well. And then this would have been like landscape fabric that you put down that was mimicking that idea, and that again could be used either in pasture or in raised beds. We typically put that down in, or again we put that down in some sort of flower bed. So I was looking at it from that point of view. When it came down to doing the test, that first bottle with nothing on it, that again would have been grass or a cover crop, we saw a lot of soil. I predicted that if it was the cover crop on top, when I've done this before, you don't get that much soil in it. My second bottle with the fabric barrier, very slow to filtrate because it was going ahead and blocking some of that soil particles from coming out. So we saw pretty clear soil here, very slow to go ahead and filter. And my last one was down here. We see a lot more soil than I thought we would with the stone, and that brings me into our improve. I think in that third bottle with the stone, if I used a smaller stone, this was like a larger stone type, like a 2A would have been perfect gravel, we would have seen more filtration there. If I had a cover crop on top of that first one, we would have seen less soil, more filtration. And the fabric on that bottle could have been a little bit thinner to allow more of the water to trickle through the layers of the soil, but ultimately was the best in this scenario. This is the standard I was looking at from Next Generation Science Standards, the role of the water and earth surface process, including infiltration, runoff, and erosion, depends on the properties and characteristics of material and surfaces it interacts with. So in my scenario, it would have interacted with the fabric, the stone, and in one case, it could have interacted with the cover crop. Connecting to the STEM practices on the chart on page 38. Overall, I think this is a great lab that shows a lot of details on this chart. So first of all, the question was provided for us. I would probably also provide a question to my students, but I could make this more inquiry-based by allowing them to come up with the question if I just gave the topic of rotational grazing and soil health. Technology was incorporated. We did do the simulation before completing this lab. I did go through that, but then ultimately took it to a pathway that I can use this lab in my classes. Mathematics is a huge account for this. I measured out the soil so that each bottle had the same amount of soil. I measured the lines to make sure I was cutting evenly on the bottles, measured the amount of water I was putting in. So this allowed really for the controls in my lab to be set up. Scientific models were used. I would not say a mathematic model wasn't used, but a scientific model was definitely used. We saw what was happening in the bottles. The bottles were clear. We saw the soil rolling down the bottles. We saw where it was catching on the fabric. I saw it coming out the end of the bottles, and ultimately that's what I then collected for data. Data was collected and easily interpreted. A few different ways we can interpret data. I just did this by clarity of the water. I think in reality that's a really poor way of looking at data collection, and in the future I would look at the weight of those waters. So if the water weighs more, we can indicate that there's more soil particles in there. That shows more erosion. You can also look at measuring how much water, so how much actually comes through the system in a set amount of time. And then we can also then as a class now discuss what would you change. So I mentioned some things I would change already, but proposing that question to the class allows for some discussion. Each group can do this a little bit different way, and they can share what they did, what they worked with. I would probably have my class come with a materials list on one day. I would go get those materials, and they would build their own system so that every group had a little bit of something different. For example, if one group wanted the sticker stone that I had and another group wanted sand, they can do that, and we can then talk about how each system was set up a little bit differently. Overall, I really think that this connected to the STEM practices on that page. Technology usage, few other things I want to hint on in that. We can see the simulation, but then we can also go ahead and talk about in industry, how are we doing soil testing? And I can get into the whole topic of the technology needed to do soil testing. I can go off of this and come into tillage of soil, and we can talk about how we till soil and the technology we use there. The simulation was a great example of a way to include technology in this, and then researching what we are doing in pastures, obviously using just a laptop, basic technology there. Thank you so much for listening to my presentation, and have a great night.